Hello everybody! Today we will build a simple iOS app that uses TensorFlow Serving for inference. There is a lot of examples that use TensorFlow models directly on the device. There are also multiple tutorials on TensorFlow Serving in Python or C++, but it's not easy to integrate them into an iOS app. I have prepared some files in this GitHub repository that help you to reproduce the result. Let's clone that first, because we will use the files. Just a quick note, you need to have Xcode, CocoaPods, Python 3 with pip and Docker installed on your Mac. I assume you have those installed, but if you don't, go ahead and install them now. In this video, we will take the simple iOS example project from the official TensorFlow repository that uses the inception model and rebuild it for the use with TensorFlow Serving. Let's start by cloning the TensorFlow repository that contains a simple example project. The iOS project uses the inception model to classify images, so we need to download the required model as described on the official TensorFlow webpage. Let's start the original project and look what it does. Change the directory to TensorFlow examples iOS simple. You can see the downloaded model in the data directory. It's around 50 megabytes. Now we can do pod install and open the project. This is an image of Grasshopper. Our test image we will run prediction on. So there is a run inference function that takes the image of Grasshopper, loads it into a tensor, and predicts what's on the image. We want to move the prediction from device to a TensorFlow server. We should be able to run it now. We can simply fix this build error by removing the third party from the include here. The only thing that the app does is to predict the Grasshopper image when you click on the Run Model button. As you can see, the model predicted, for example, a military uniform. So let's move this part onto a TensorFlow server. Before we move on to the TensorFlow serving in the app, we have to prepare the environment. There is a C++ example in the TensorFlow serving repository. Let's take a look at it. It uses the prediction service to do similar prediction as the one in our simple app. We don't use this code for multiple reasons. For example, it cannot be used directly in our iOS app. It also uses a different model, and it sends the image data as a string. Also note that this example uses gRPC to communicate with the server. You can send data to TensorFlow Serving either through REST or through gRPC. The gRPC is maybe a bit more complicated to use, but it's much faster than REST, at least if you are working with images, so it's worth the effort. Anyway, the important information we take from this file is that we need the prediction service to communicate with the TensorFlow Serving. The problem is that in the TensorFlow Serving repository, there is only a PredictionService.proto file that we cannot use directly. We need to compile it into a gRPC readable file. To explain how this should be done, we'll use an example from the official gRPC repository. You can see that the gRPC client uses a pbrpch file, which was generated from the root guide proto file. The compilation happens in the podspec file. The podspec file defines the location of our proto files. The proto files are compiled in the prepare command. I've prepared a pod spec file in my GitHub repository that we have cloned at the beginning. Let's copy that file into our project. Let's look at the gRPC pod file to see how it should be included. Copy the line from the pod file and adjust the name, which in this case is PredictionService. So let's generate our prediction service. Unfortunately, the prediction service proto file has multiple dependencies, and I don't recommend to generate all of them. I've provided a list of proto files that we will need for the prediction service to work properly. Even if you change the model or data you want to send, you will still use the same prediction service, so those files cover all of your needs. Now it's time to get the prediction service proto file that can be located in the Tensorflow Serving repository. Let's clone the Tensorflow Serving module. Some of the Tensorflow Serving profiles depend on other TensorFlow profiles. Let's move the Tensorflow Serving module to the TensorFlow directory so that we have all the files in one place. Let's go back to the example project. One more thing before generating profiles from proto definitions is that you have to add a prefix option to the classification.proto file. Otherwise, you will get an error when compiling the app in Xcode because of the redefinition of class error. You should use prefixes that are between 3 to 5 uppercase characters long, as recommended by Apple. You can read more about it in the link in the description. For this video, let's use the PRSV prefix that stands for Prediction Service. Choose whatever you want, it doesn't have any impact on the code. Now we can rebuild the project by calling pod install, which includes gRPC dependencies and compiles our proto files. To fix this warning, we simply add inherited flag to the build settings. Open the project, go to tf simple example, build settings, and search for library search path. Then simply paste the inherited flag. Now go to the view controller code and include the prediction service. You can find the include statements in the GitHub repository in run model view controller file. Simply copy and paste it to our project. Now we could build and use the prediction service on the client side. But before we do that, we need to prepare our server side. The TensorFlow sample app uses the downloaded inception graph, but TensorFlow Serving expects a saved model that contains a serve flag. I have prepared a Python script that converts the graph into a saved model, which can be used in the TensorFlow Serving. Copy the script from the cloned repository to the data directory. The script requires the TensorFlow library to be installed. You can install it by calling pip3 install TensorFlow. Run it and you will see an inception saved model directory that contains a saved model. You can verify that converted model with the saved model CLI that comes with TensorFlow and pip. Now let's try to serve the model in Tensorflow Serving. We will run it locally in Docker, since that's the recommended way. Don't forget to start Docker. Then open terminal and type docker pool tensorflow/serving. Now we can run TensorFlow Serving with our saved model in Docker. Now that we have everything prepared, let's code it. Go back to Xcode and jump to the viewController.m file. The inference is invoked in the run inference on image function. So let's duplicate it and rename it to run remote inference on image. The original method runs in the main thread, which is bad practice. So we adjust our newly created run remote inference on image to run in background. Therefore, it won't return string anymore. The label will be updated directly in the function. We have to adjust the calls of the function now. We send the text view as a reference so that we can update it inside of method. Now let's move on to the method body. We duplicate it as well and rename it accordingly. Change the return type and the name, and copy the text view attribute from our definition. We can comment the whole block of the code where TensorFlow preparation happens. We don't need it anymore. We also have to comment the TensorFlow prediction code since it's not initialized anymore. Shorten the loaded message in the result for now and comment out the rest till the evaluation part. We will need that part since we still want to evaluate the result. Comment the code between input layer and output. Now we can remove the commented block entirely. I have prepared the class in a GitHub repository, so copy the code and paste it directly after image load. You can use either a code snippet from the patch file or copy the entire viewController file. Here we initialize the gRPC to communicate with our local TensorFlow server that runs in Docker. Initialize PredictionService, fill the data and do the prediction. I have used different name for the UI text view, so I have to adjust it. Now, move the evaluation code to the prediction result processing. You can find a comment that says reuse old code. We also need a new getTopEnd function because we want to read the result directly from result float array that contains the confidence scores. Replace the old output array with our confidence scores. Let's duplicate it and adjust it. We only need to change the calls. Change the data type of predictions to GPP float array and adjust the code. The app is ready to test now, so hit the Run button. The result is the same, just achieved by a different approach. You can completely remove the old code and TensorFlow library from your project and do the inference solely on the server. We reused the label and image loading, the evaluation code, and implemented our version for predicting. I hope this tutorial helped you. Hit the like button if you enjoyed it and subscribe if you want to get updated about similar videos. Thank you and see you next time.